Okay, in this video we are going to be talking about integrals with radicals. They come up a lot when you are first learning. I mean, they always come up, but when you're first learning, some people are a little intimidated. I don't think you need to be. Let's go through some and see what we can do. So the first thing is you basically don't want to work with radicals. So what we're going to do is we're going to convert to rational exponents, which means you need to know how to do that. So if you have something that looks like the nth root of a to the m, the way you're going to convert that is it's going to be a raised to the m divided by n. So that's the first step to success on these, is to remember that. Now, usually m is going to be 1. Not always, but often. So you will frequently get a to the 1 over n as the thing that you're trying to integrate. You also will occasionally run into, or maybe often, run into the radical in the denominator. That's okay. Just bring it up to the numerator with a negative exponent. So this would have been 1 over a to the m over n. This is going to become a to the negative and then m over n. So that's the first thing. You do not want to deal with radicals at all. That's kind of the secret to integrating radicals, is don't turn them into rational exponents. Also, on virtually every single one of these problems, you're going to use u-substitution. As you get more used to it, you will do that in your head, but at the outset, there's nothing wrong with showing the work, and long term, there's nothing wrong with showing the work. Do not forget that you have to substitute for dx. That's the main thing once you're really good at these that some people forget to do. All right, now let's take a look at a bunch of examples. So first up, we're going to integrate the square root of x minus 5 dx. Step 1 is rewrite this thing using rational exponents, so that's going to be if there's no number there, right? If there's no value shown for n, that's going to be 2 because it's square root. So this will be to the 1 over 2. So we're going to write it as x minus 5 to the 1/2. You can do u substitution on this with u is equal to x minus 5, which means that du is just dx. I'm not going to actually do it because if du is just dx, you can just integrate this thing straight away. We're going to now do plus 1 times the reciprocal. So 1/2 plus 1 is 3/2. The reciprocal is 2/3. And then our quantity, x minus 5 to the 3/2 plus c. And that's what we get. So there's no reason to be afraid of these. Let's take a look at another one. So we have the integral of the square root of 5x minus 8 dx. Again, step 1 is just rewrite it with rational exponents. I think this is a really good step to go through. So again, it's 5x minus 8 to the first is there, and then you're doing the square root. So n is 2, so we get to the 1/2. That's the most common thing that you're going to run into. I'm going to actually do the u substitution here. So I'll say u is 5x minus 8, which means that du is 5 dx. But I want to sub for dx, so I'm going to say that 1/5 du is equal to dx. So now we're going to do all of our substitutions. So dx is 1/5 du. So I'll get a 1/5 that I pull out, and I have u to the 1/2 du. Now, the 1/5 is just going to hang around. If we add 1 to the exponent, because we're reversing the power rule, we get 1/2 plus 1 is 3/2, so the reciprocal is 2/3. And then u to the 3/2 plus c. And then we want to go back to x's, so u is 5x minus 8. Also simplify that 1/5 times 2/3, so 2 over 15, and then 5x minus 8 to the 3/2 plus c. All right, let's take a look at another one. So we have the integral of x squared times the square root of 6x cubed plus 5. So you come to find out, for the most part, when you're doing antiderivatives or integrals, if there's a radical, almost 100% of the time, u is going to be the thing inside the radical. There are more advanced problems where you're going to want to do something else, but at the outset, for sure, try u as the thing inside the radical, which means that the coefficient there, that x squared, is probably just a part of du, and you probably don't really need to worry about it. You just do your substitution and see what happens. So I'm going to rewrite this with rational exponents and then try to take care of it. So x squared just hangs out. We're going to get 6x cubed plus 5 to the 1/2 dx. So the u is going to be 6x cubed plus 5, which means du is going to be 18x squared dx. Now, I already have an x squared and a dx in the problem, and so I want to say that 1 over 18 du is x squared dx, and we will replace x squared dx with 1 over 18 du. So this is going to be our 1 over 18 du. I'm going to pull out the 1 over 18. integral of u to the 1/2 du. And now we're just integrating. So 1 over 18, add 1 to the exponent gives us 3/2, reciprocal is 2/3, and then to the 3/2 plus c. So then you have 2 over 18 is 1 over 9, 9 times 3 is 27. So we get 1 over 27, 6x cubed plus 5 to the 3/2 plus c. All right, let's take a look at another one. All right, we got the integral of 5x cubed, the 5th root of 8x to the 4th minus 3. So I'm going to follow my own rule where I'm basically going to try to make u equal the thing inside the radical, rewrite with rational exponents, and also that 5 that's there, I'm just going to pull it out immediately as a constant multiple. So 5, and then the integral of x cubed, and then this will become the quantity 8x to the 4th minus 3 to the 1/5, because this time we're doing the 5th root. The previous ones, and the most common, is the square root. So usually, probably usually you get 1/2. In this case, we're getting 1/5. Not a big deal. Let's make u equal 8x to the 4th minus 3, which means that du is 32x cubed dx. Look at the problem. We have an x cubed and a dx, which is why I say don't really worry about that. Du is probably going to take care of it. I'm going to make 1 over 32 du be x cubed dx, and we're ready to substitute. So the 5 is still there. The x cubed and the dx are going to be 1 over 32 du. Let's pull out the 1 over 32. And then the integral of the x cubed and dx are done. They're just going to be du. So we just have u to the 1/5 and a du. All right, so we're going to do plus 1 times the reciprocal. So 5 over 32. Add 1 to the exponent, you get 6/5. The reciprocal is 5/6. And then u to the 6/5 plus c. And then we want to go back to x's and also take care of kind of cleaning up that coefficient. So 25 over 192, and then 8x to the 4th minus 3 to the 6/5 plus c. All right, how many more am I doing? I'm doing 2 more problems. Let's keep going. All right, integral of x over the cube root of 5x squared plus 12. Step 1 is rational exponents. Just go to it. It's going to make your life a lot easier. So the x just stays. We're going to have 5x squared plus 12 to the negative 1/3. So if that radical had been in the numerator, it'd be positive 1/3. We're in the denominator, so it becomes negative 1/3. All right, let's make our substitution. U is going to be the thing inside of the radical. So U is 5x squared plus 12, which makes du 10x dx. We have an x and a dx, so I just need to bring the 10 over to the other side. So I'm going to say 1/10 du is x dx. And we're ready to substitute and integrate and get our answer. So x dx is going to be 1/10 du, so we'll pull out 1/10, and then we'll have the integral of u to the negative 1/3 du. All right, so 1/10 is still here. You add 1 to the exponent, and you get 2/3. The reciprocal is 3/2. U to the 2/3, and then plus c. And then finally, we go back to x's, so we'll get 3 over 20. And then u is 5x squared plus 12 to the 2/3 plus c. I should probably mention that I will leave answers as rational exponents. I don't really like radicals. I mean, on like the AP exam, I will write it as a radical if I have to match an answer choice. But I do think it's more common in calculus to work with rational exponents. It doesn't bother me at all. I prefer it. All right, let's do one last problem in this video. We've got the integral of 2x minus 3 over the 7th root of 2x squared minus 6x plus 5 dx. Okay, rational exponents, step 1. Make sure you put parentheses around this 2x minus 3. Just from a notation standpoint, like you're going to take 2x minus 3 multiplied by the whole thing that you're bringing up here. And then this will become to the negative 1/7 because it would have been to the 1/7 in the denominator. In the numerator, it's to the negative 1/7. Now we kind of do our thing. So I'm going to make u the thing inside the radical. And then du will be 4x minus 6 dx. I like to put parentheses. Everyone should put parentheses around the 4x minus 6. I do see a lot of people not do that, but I think they're just like not thinking. I don't really know. There should definitely be parentheses there because that dx applies to both parts, to the 4x and to the minus 6. So we have this. Now this one's a little bit trickier because when you look up at what you have a 2x minus 3 and a dx. You don't have a 4x minus 6. So what I'm going to do is I'm just going to multiply both sides of my du equation by 1/2. And then that'll give me 1/2 du is the quantity 2x minus 3 dx. So we have to balance out our du dx situation so that we can make a straight substitution. So 2x minus 3 dx is 1/2 du. Pull out the 1/2, integral u to the negative 1/7, and then the dx becomes du, but also that 2x minus 3 is a part of it. There's a lot going on there. All right, let's integrate. So 1/2. Add 1 to the exponent, gives you 6/7. The reciprocal is 7/6. And then u to the 6/7 plus c. And then finally, we want to go back to x's. So we get 7/12, quantity 2x squared minus 6x plus 5 to the 6/7 plus c. All right, so that's a lot of examples of how we can integrate when we have a radical. It's a really good practice. You're going to run into these a lot. I hope this was helpful, and good luck.